Yes, Dhananji, what is an algorithm? Yes, when you're given a problem, we have to have a method of solving it. The step by step a method to solve a problem, we call it an algorithm. So when you are going to develop algorithm, you have to think about what are the inputs, what are the output, and how do you convert input to the output. So that is what we call process, right? Then only we can create an algorithm. So for example, in this particular case, if you want to create a fruit salad, so there are few steps. So first of all, you can find out the various fruits. Then you can prepare them, meaning you can wash all the fruits. Then you can cut those fruits, and then you can put into a bowl and mix sugar, right? And then you can mix well. And finally, you can serve. So you see that when you say that, okay, given a problem like making a fruit salad, there are series of steps are involving, and you have to follow one after the other, right? So this sequence is we called an algorithm, right? Now, similarly, making a chocolate cake. So here is an algorithm for this. So you have a series of steps starting from start. So usually when we represent algorithm, we have that start and end that indicate start of the algorithm, right? Then you are going to put the steps one after the other. So which means you have to follow these steps. So in this particular case, you have to start from step 1, then 2, then 3, and so on. You can go up to step 12, right? So that's we call algorithm. Similarly, we discuss like we are most of the time when it comes to computers, we perform calculations. Like something like this, we can easily implement in a computer, like for example, finding area of a rectangle. Now, as I told you earlier, before you write down the algorithm, first of all, you look at what are the inputs. We know that we need to know length and width. So those are the inputs. The next is the output. So what is the output? We have to get the area of a rectangle. Now, what is the process? So to find the area, we know that we have to multiply length by width. So which means now you can write down the steps. You can start, you can get the length, get the width, and then you perform the calculate the area, and then you output. Although it says get, it should output the area of a rectangle. Now you can write this simply in words like this. Sometimes I told you we call it pseudocode. But since you are a beginners and still you are in grade 9, the easiest way to learn algorithm is use of flowcharts. In flowcharts, you will have different graphical symbols. Now, the symbol, for example, is used to indicate start and end. So any flowchart you will get, you will see this symbol in the beginning as well as at the end, right? And then when you want to, get inputs and the output, we have used this shape. This is parallelogram, right? And this shape we will use to indicate input and output. So now, for example, previous step, getting the length and the width as well as output the area. So we have to use this symbol. The next one is a rectangle, especially when you want to show an action or a process, we can use a rectangle. Then diamond shape block like this, we can use to indicate a condition or decision making. So which means in some programs we will see, depend on the decision we make, can take different paths. So that's what you will see in these arrows. So here, if the decision is yes, you are going to take this path. If it is no, you are going to take this path. And finally, arrows indicate the direction. So arrows are helpful, especially when you are reading an algorithm. So where to go, right? From start to the end. Right. So this is the flow chart for creating a fruit salad. So start and end, we discussed this, and this is getting various fruits at this input. And then finally the output, you serve the fruit salad. And in between you have a lot of rectangles, which indicates the different actions. Right. And the next one is our problem, getting the length, getting the width, as well as finding area of a rectangle. And then finally you output the area. So that is how we represent flow charts. Right. So as a summary of this, right, before the problem is resolved, you need to analyze. What do you mean by analyze here? Identify input, identify output, and identify what is the process. So there will be an input, output, process when solving a problem, right? Okay. And then we will discuss, we will have a step, all step needed to solve a problem. We can say as an algorithm. A method set out in order, including all steps needed to solve any problem, is identified as an algorithm. So any standard algorithm, you should have start and end, and flowcharts are used to draw algorithms using different graphical symbols. Okay, so that's what we need in grade 6. And if you look at what we have for the workbook as well, so we have to go to 46. I think we have done a couple of things. 46. Yes, we have 41, 43, 44. Okay. Right. So what are the three main components of a problem? Yes, Dhananji? Let me.
Process and output.
Exactly. Input, process, and output. So what do you mean by input? Things that we enter to the algorithm, right? So those are called inputs. Then things that we get out, right, we call output. So getting input from the output, the method we call process, right? So hopefully you can do this. Then write the input, process, and output to find perimeter of a rectangle. Okay, so can you tell me what are the inputs? Yes, we have to have, similar to previous one, we need to have length and width, right? So we put down, it will be easy. So we have to have the length, we can have length and width. So what is the output? Let me. Yes, let me. What is the output of this? What we are supposed to do? What we are supposed to find here? Yes, Dhananji.
Perimeter of the rectangle.
Exactly. So we have to have perimeter. So that's what the output. So given length and width, how do you find the perimeter? Just let me. So how do you find the perimeter? So we can say perimeter equals what? Equals what? Yes, Dhananjay?
2 multiplied by length plus width.
Yes. 2 into, we can have length plus width. Right. Okay. Good. Right. Again, we have making a cup of tea, and then we have given you take water, tea leaves, sugar, milk powder, boil water, add tea leaves to boil water, mix milk powder and sugar, add plain tea to the above mixture, prepare a cup of tea. Right. So what is the input? We'll start with Netmi. Yes, you are trying to prepare a cup of tea. And to prepare a cup of tea, what do you need? What are the inputs? Yes, Senhiru, what do you need? Tell me. Water, right? Okay. So we can say it's water, tea leaves, sugar, and milk, right? So what is output? Let me. So what is the output? Let me. Dhananjay?
Cup of tea.
Yes. This should be the cup of tea. So what is the process? Yes. So in the, actually this is asked to write down the alphabets. So we can say A simply, then we can say F, yes, and then we can put here B, C, D, E, right? So that's a simple. And then the other things I think we have done. So these are the things that we have to do. I don't think it is that difficult. And then you are supposed to draw flow charts for those. Right. Okay, I think we'll finish grade 6 with that. So let's move on to grade 7. Right. Now let's go to program development. It's page number 46. Right. So in grade 7, we start with program development. The first thing that we are going to discuss is called decomposing the problem. Decompose means when you have a very complex problem, you are trying to uh, create or separate smaller problems. Complex problem means it's a bigger problem. So you take multiple smaller problems, you solve it. So that's how we are going to do. Right? So complex objects you see in the figure as well. When you say decompose, you in this particular case decompose a code into shape, you are getting this. If you decompose a code into the background colors, you get this, right? So likewise, when you given a very complex problem, you broke down into several smaller problems. We will call smaller sub problems, right? So we call it's a smaller sub problems. We use the term sub problems, right? And then we can solve these sub problems. So decomposition means when you have a very complex problem, you can separate or you can break them into several sub problems. Now, if you ask me like why we have to do this, now instead of saving a very complex problem, it is easy to solve a smaller problem. And when the problem is smaller, it is easy to understand. It is easy to describe and it is easy to analyze, right? So now we have discussed how we are going to do this. Now, for example, in this example, look at this, simple mathematical calculation, right? So you have, 5 into 6 plus 4 divided by 2. So what you could do is you can separate out. You can separate out the multiplication, then you can separate out the addition, then you can separate out the division. So in this particular case, first of all, you multiply, you get 30. And for that 30, you add 4. And then finally, you divide by 2, you can get the solution. So it is true for computers as well. Whenever you can talk about, right, we can make use of this decomposition. Now remember the flowchart that we have discussed earlier, right? So all the examples we have discussed so far, we execute all the instruction from top to bottom. අපි පොතේ මුල ඉඳන් අගටම මේවා execute කරා මේ වෙනකම්. But this time we are going to change it. Now, based on some decisions, we are going to take different paths. Now, for example, here we have a decision, and according to the decision, you are going to take different paths. So this is called selection. Now, it's like, is it raining? If it is raining, you take the umbrella. If not, you don't have to take it. Similarly, another one is called repetition. Repetition means you are going to repeat something. That you see the arrow goes up, which means you check the condition, and depend on the condition, you are going to execute these two instructions or multiple times, right? Okay. Now let's start with the sequence. As the name says, sequence means you are going to execute everything sequentially, right? So if you are getting to put a cover to a textbook, so here you see all these steps, you are going to execute one after the other, right? The first step, you cut the paper to cover the textbooks in suitable size. You cut it, then you place the textbook, fold outer cover inward, paste inside the close the edges of the outer cover, and label the textbook. So simply, for this flow chart, we have to execute all the instructions from top to bottom. So this is an example for sequence. And here is another example for finding perimeter of rectangle. Right? Okay, so area and perimeter both. So we will get the length and width. Then you find area and perimeter, and then you display perimeter. Right? Again, you will notice here, everything is executed one after the other. First of all, you get an length and width. Next, you calculate area and perimeter. Next, you display the area and perimeter. So you see everything is executed from top to bottom. Right. Okay, now we will look at the other two structures. Now we have already discussed sequence. The next one we call is selection. Right now, for example, in this figure, let's say you drive a car, and if you come to this point, now you have to decide whether to go in blue colored side, that means that road, or red colored side. So you have to make a decision. Okay. So similarly, right, we can represent flow charts. Now, for example, in this example, we will have a fan. But to get the working the fan, you have to have power, electricity. So to represent that one, when you start, you switch on. If you have power, then what will happen? Fan will work. Okay. So fan will work. If there are no power, then fan will not working. Right. Now, similarly, if you take repetition, now what is repetition? You are going to do something again and again. Right. For example, if you look at in this figure, you will see a natural water cycle, and it repeats the same thing again and again and again and again. Right. So this is again repetitive task. Let's say you are putting coins to a till. Right. Whenever you get some extra money from your parent, right, maybe you can put it in the till. Now you take till to put a money, right? Then you put money and you check whether it's full. If it is not full, then you can insert another, right? You can keep on doing that until this till is full. But whenever the till is full, then you are going to stop this. Right. So here is a one example. You take a pen and you are trying to write it. If you have ink only, you can write, otherwise you can't. And the second one, what you see here, you start write and then you check the condition. So all these possibilities are there. Right. Now let's look at how to do this with Scratch. So in this case, I'm going to use the online version, but then you can download later on and install. But for the today's lesson, I'm going to use graphical interface in the web browser. Let me give you the address. Right. Let me share my web page. So here is a page. And then I'm trying to find the Scratch. So if you want, you can download and install, but for the time being, I'm going to start in the browser itself. Right? And you should see something like this. So when you get ready, please let me know, then I'm going to start. Once you see this, let me know, then we can start. So I put the link in the chat. So go through the chat, scratch. So you have to select create. When you get to create, you get the web version. Okay, let me try this. I hope in phone also you can do this. Let me check. You go to browser. Yes, you can do it in mobile as well. Could be a bit slow, but still you can manage, right? I hope you can do this. Right. Dhananji, are you ready?
Yes, sir.
You got this. Right. Okay. So few things I have to tell you. Now, first of all, there are few places we need to know what we are going to do. So this is called the stage. The stage means whatever we do here will be represented here, right? And then we have a script area. So this is called script area. So in the script area, right? Let me annotate them. So this is the stage, right? And this is the script area. So this is where we put the commands. And here we have the block palette. Right. So usually we will have these. And then also here, right, we have a spirite list. That means the characters. So let me put. So right now we have only one sprite. Right. Okay. Now with that one, now we are ready. Now we are going to do, let's see what we could do here. Right. So a few things I want to show you. So in here, the stage, we have coordinates, especially in the middle of this. What do you mean by middle? So if you take this, let's approximate, and this is horizontal, and then let's say this is vertical, right? So in the middle point, I hope you have done this in mathematics. You know how to draw graphs, right? Do you know how to draw graphs? Right. So in here, in the middle point, right? Let me remove the sprite for the time being, right? And then, so the middle point, usually it will be 0, 0. So that means the x-axis is here, right? So this is x and this is y. So this axis is y. So when you say 0, 0, it means x is 0 and y is 0. That's how it works, right? So when you go here and there, you can see how the values are changes, right? Now, for example, let me take a ball. Now the ball, you see, if you put in the center, exactly the center, you should get 0, 0. So manually what you could do is you can put 0 and 0. If you put 0, 0, this is exactly the point 0, 0, right? I think slightly should be slightly down. And then if you want to go to top, you can go to top. So you see what will happen. The value of y increases, right? Y increases. So it's the maximum value is 180, right? And here also, when you go here, the maximum value will be about, I think, 240. Yes, that's what we have given. Yes, 240. So which means if we put down these values, right? So here we will have 240, here we have 180. So that means this point, we can say it's 240, 180. 240 and 180. Right. So that's what. So likewise, if you come this side, it will be minus 240 to minus 180. Minus 240 to minus 180. Yes. How do you check? You can take the ball and you can see XY coordinates. Approximately it's correct, but if you just type this, you will see. So instead of here, you can say 240 and then we can say 180. Right? So this is exactly the point that you see. That's where the stage is. Okay. Now that's about the stage. And then we will also have start, run button, stop button. So this is called start, run button, and this is called stop button. So these we want to know. And this is maximizing. So when you click it, you get the full page. Right. I think now you are kind of ready for that. Right? You are kind of ready. So the first set we are going to discuss motion. So we see when you click move, it changes the direction. 10 step always. You see here now is 127. When I click it, it becomes 137. Then you can turn. Now the direction is 90 degrees. When you turn, it becomes 105. So it goes on like this. Similarly, you can turn the other side as well, right? So you can work on this. And the point direction is looking at a specific direction. So 90 degrees. This is 180. This is minus 90. And this is again 90 degrees, right? So this is helpful for you want to do this, right? Now let's do a simple example. Now I'm going to remove Abby. So for that, I will go here. I will remove her from here. Now we'll have a ball. Now ball in the random position. So I will remove these as well, right? So you can remove by moving towards the left hand side. So there's no, commands applied to the ball. But this time I'm going to always start with 0. So to say that we are to go, we can click like this, go to X and Y. So it's a middle, let's say the middle point we discussed earlier, it will be 0. So this is also 0. And when you click, you will notice right now the ball is 6 in X direction, 124, Y direction 6. When you click, notice this becomes X0, Y0. So it's in the middle now. Now let's move 100 steps. Now once you do this, let's put 100 steps, right? So when you click it, so it shows this one, move 100 steps. So the direction is the problem. Let me put the direction as 90. Otherwise, this might create some issues in my case. So it's 90. So when you click it, it will always be 100. The direction should be this, center to 100. But you can't see this, isn't it? It's because it's really fast, right? You don't see. It will come here and then it will go back. But you can't see here. But later on, we will discuss. You can control. You can say, wait 1 second, right? So I'll come to this one. So when I click now, it will first go to the center. After 1 second, it will go back. You see? So see, without this one, we can't see this because it's really quick. When you click it, it will come back, and so you don't see that effect. But if you put wait 1, now what will happen when you click it? It will come to the middle point. After 1 second, it will go back. Right, now I will remove wait, because wait I will discuss later on. But let's these two. And to start with, we will have a block, right? Whenever we want to start something, usually we prefer to start this one. Right? And if you click here, it will run. Again, like in previous case, you don't see this because it's quick. Now the second one is looks. So let me remove all of this. So let's look at looks. The appearance, right? So you can do a lot from here as well. Now you can say something. You can say something. Say hello for 2 seconds. And it will remove. Think 2 seconds. First of all, it says hello. After 2 seconds, it says right? You see, this is called looks. Now it's very sometimes interesting to work on these looks. Now, especially not with the ball, but some other characters. Let's take Abby again. Now this time I'm going to write some code for Abby. Okay. So what I'm going to do is switch costume. So you see there are 4. First of all, I'll put the first one. I'll make a duplicate. Now I'm going to say B, second one. Again duplicate. Now let me put C. Again duplicate. Again B. So that means costumes, the appearance. So when you click now, you will see the image first. Okay, I be like this. The second one, kind of thinking something. Yes, cheerful. Fourth one, okay, back. So you can combine like in earlier, but again, the problem is you don't see this. It'll always like this, right? But if you put a weight in between, let's take a weight. I put in between. And if I click it, every 1 second, it'll change the effect. Okay. So that looks. Now the sound, third one. So let me remove this. You can use musical instruments, basic notes. You can create sounds and sound patterns. Right? So go to this one, play. You see the pop sound, right? Change sound, or you can record it if you want. Yeah, you can try recording if you want. There are few other things as well. So you can try with all these given the blocks. Next, events. Already we have used this. When you click the flag, what you got to do? Likewise, you can specify some keyboards. When you use space, what happens? You can change this. Let me start with a new character. Okay, now let me explain the sequence. Remember, we were discussing earlier that we are going to use, right, uh, sequence, right? So let me start with the control block first, because whenever you have, so you have the events, you are going to click this, right? Now we have this character. We are going to make him to say days of the week, right? So I'm going to say, okay, say Sunday, right? Then I'm going to say Monday. Likewise, we can say Tuesday. Wednesday. Thursday. And finally, we can have Saturday. Now, if you run this, if you click here, you see it will start with Sunday, Monday, keep on counting like this. And this is exactly the example for sequence. Finished? If you finish, please send me a screenshot for my WhatsApp. Finished? Nanji, have you finished?
No, sir.
Okay, take your time.